Okay, Unites, this is the collapsing can with full explanation this time. What I've done is I've bought a can of Turkish energy drink to give me Turkish energy, and I've poured it out because it's disgusting. I don't like that stuff. What I'm doing is going to cheat a little bit. I'm going to put some boiling water in here, or boiled water, so it's quite hot. Okay, that's not super important. Remember, because liquids don't expand very much when they're heated. Okay, this is just to speed the experiment up a little bit. Now, what I've just done is I've put some more energy into this because I put hot water in there. So there's a lot more energy in here. Because the molecules have got more energy, they create more pressure, and that actually pushes molecules out of there. Because remember, we've got an area of high pressure and lower pressure outside, so that wants to equalize, it wants to reach equilibrium, so a lot of the molecules go out. So that means if we take the same volume of inside the can and the same volume of air outside, there are actually less molecules in here. Okay, that's ignoring the water. Okay, what I'm going to do is going to heat it up and I'm going to crush the can with the full explanation. And of course, I need to make sure that I'm safe, so I'm going to put on safety glasses, and so that I don't, run the risk of, being horribly injured. Okay, so what I'm going to do is I'm going to do this homemade experiment. Do not do this at home, okay, because it feels like it might be kind of dangerous. Okay, so get my stove going, and I'm going to try and do this hands-free because I feel like it could be very dangerous. So let's just set up my scene. Now what is going to happen here is the molecules are going to get even hotter, right? They're going to get way hotter because, the molecules are going to gain loads more energy, all right? So here I am using 2 spoons to do this. Okay, so I'm just going to heat this up more. And as I heat it up more, as the water boils, that's going to blow more molecules out the top. Because remember, they're getting more energy, and they are. That means the pressure inside increases. And remember, they want to go from the area of high pressure to low. Okay, so we've got high pressure happening in the can, but that high pressure equalizes as the molecules leave. Okay, so if it's starting to boil, you have to bear with me for a minute here. It's not quite as effective as a Bunsen burner. And then what's going to happen is I put this into the cold water in the glass bowl. And then what happens? Well, the molecules inside, they lose a lot of energy because they cool down. And because they lose a lot of energy, that means the pressure inside suddenly decreases. So what we've got is an area of high pressure outside and an area of low pressure inside. Okay, and of course, what it wants to do is it wants those pressures to be equal. So the Earth's atmosphere crushes the can, reducing its volume and bringing the pressure inside to the same level as Earth's atmosphere. Come on, boil. Okay, you can hopefully see it starting to boil now. You can see some steam coming out the top. You can just kind of skip this video forward a bit now. I've talked about all the science. You can skip forward to the bit where I crush it, but I'll go back over what actually happens again. And hopefully these spoons don't start to get really hot. Because remember, metals are very good conductors of heat. I could try this right now, but really this seems to work best whenever the water's fully boiling. One thing we need to remember, of course, is that heat, because it travels from hot to cold, a lot of the heat, although this can is heating up, the heat it gains, some of it is leaving because the room's quite cold right now because it's November. At least the room's getting warmer though. Oh, there we go. Need to put it right in the flame as it turns out. Okay, so it's boiling away, it's bumping because of the bubbles forming inside. It's boiling a bit better. I mean, you can see this happen in the original video, so if it doesn't work, it doesn't work. It's not a huge problem. So let's try it. Yeah, all right. I'm very surprised it worked out well. But look, okay, so you can see it's cooled right down. It's cooled down enough that I can quite easily hold it, even though it's just been boiling under the flame of the, let me take these ridiculous glasses off, under the flame of the stove. So it's been crushed because, remember, when I cool it down, the gas inside lost a lot of energy. That means it was making much less pressure, and so because it had a much lower pressure, it couldn't really suck in very well because it was in water, which is much thicker than air. So what it did was Earth's atmosphere, air crushed it. It was crushed by Earth's atmosphere. Now, that might seem very weird, and it is kind of weird. It's hard to think about because we don't really notice Earth's atmosphere. We don't notice that pressure, even though there are many, many kilos of air pushing down on our heads right now. And that's because we've got the same pressure inside our bodies, more or less, as the Earth's, as the atmosphere. We do notice those changes when we fly, for example, when we raise up in the air, or even if you drive in a car up a steep mountain road, and you will notice your ears start to pop because what you've got is a slightly higher pressure inside your ears, behind your tympanic membrane, your eardrum, than there is outside. So what obviously happens is that we've got that area of higher pressure wants to push out into that area of lower pressure. They want to get that equilibrium, and because there's a bit of skin, hopefully, on your eardrum, then it doesn't allow that to happen unless you swallow. You've got these little tubes inside your skull which link the inside of your ear into your throat, to your trachea, and that will help you to equalize the pressure. So that's why, if your ears are popping when you're flying, it sometimes helps to have a drink. Anyway, pressure.